So when we are talking about polar equations, we are looking at equations in the form of R equals. So when we take a look at our equations in the form of R is equal to f of theta, where R is a differentiable function, we can express this form parametrically in terms of the parameter theta by substituting f of theta in for R. Remember, in polar we have x is equal to R cosine theta, y is equal to R sine theta. So this is how we're going to have to find the derivative, find the dy dx when we're considering our polar curves. So dy dx in terms of our polar is going to be equal to dy d theta divided by dx d theta. Now, the issue is going to become when we want to find dx d theta. Because what rule are we going to have to use in order to find the derivative of f of theta cosine of theta? Product rule. So my dx d theta I know is going to be f prime of theta cosine of theta plus f of theta times, what's the derivative of cosine theta? Negative sine theta. So it's going to be minus f of theta sine of theta. So now when I find my dy d theta, again, what rule am I going to have to use to find dy d theta? Again, I have to use my product rule. So f prime of theta times sine theta plus f of theta times the derivative of sine theta, which is a cosine theta. So now this brings me when I want to find dy dx in terms of my polar equations. What I'm going to have to do is, again, dy d theta, remember, is my f prime of theta sine of theta plus f of theta cosine of theta divided by my dx d theta, which I found to be f prime of theta cosine of theta minus f of theta sine theta. So this is how you find the derivative of x and y with respect to theta. Do you have to memorize this formula? If you really love memorizing stuff, you can. But you guys have enough other stuff to remember. You just have to remember you have to find your dy d theta, find your dx d theta, and then just plug it in. But again, that is a formula if you want to memorize it. I don't. I just simply do dy d theta, dx d theta, and I plug it in. All right, so any questions on that? So again, once we find dy dx, just like I had to do with my parametrics, we have the horizontal vertical line, vertical tangent lines, horizontal tangent line problems. So remember to find a horizontal tangent line. We set the numerator equal to 0. So we want to take dy d theta and set it equal to 0, and then also verify that dx d theta is not equal to 0. Vertical tangent lines. You set the denominator equal to 0. Again, your dx d theta is going to be equal to 0, and we verify that dy d theta is not equal to 0. With polar curves, they give a special name to the place where both dy d theta and dx d theta is equal to 0. We call this a singular point. And this is where you set both the numerator and denominator equal to 0. So this is where the values where dy d theta and dx d theta are equal to 0. Now, the singular point, now that you know how to graph your polar curves, take a look at the graph of a cardioid. The best way I can describe where a singular point is going to occur is let's take a look at a cardioid. We know the cardioid's in the shape of a heart. The indentation is at the pole. So it looks something, for example, like this. That singular point is going to appear where you see that indentation right there, where that heart, where that point of that heart is forming. It's forming that sharp point in the curve. So that's that location where you don't have a horizontal or vertical tangent line. It's forming that point right there in the curve. So that's what they refer to as the singular point. So, for example, find the slope of the tangent line to the circle r equals 4 cosine theta at the point where theta is equal to pi over 4. So again, when we talk about slope, I know I'm talking about the derivative. So I want to find dy dx, which I know when I'm dealing with polar curves, it's going to be my dy d theta divided by dx d theta. And again, I'm going to evaluate this at the angle theta is equal to pi over 4. So now in polar, remember we have the formula x is equal to r cosine theta, y is equal to r sine theta. So the first thing you have to do is you have to replace. You have to take out the r and replace it with the 4 cosine theta. So in my equation x equals r cosine theta, I'm going to take out the r and I'm going to replace it with 4 cosine theta. Well, what is 4 cosine theta times cosine theta? That's going to give me 4 cosine squared theta. So then y is equal to r sine theta. Again, I'm going to take the r out, replace it with the 4 cosine theta. So y is equal to 4 cosine theta times sine theta. So any questions on how I found that x equals 4 cosine theta and y equals 4 cosine theta sine theta? Now, like I said, before we can actually find dy dx, we want to first then go ahead and let's figure out dx d theta. So now remember, when I write 4 cosine squared theta, that's actually equivalent to 4 times the cosine of theta to the second power. Remember, when you have a trig function squared, it's actually the quantity. So the question is, how am I going to differentiate 4 cosine squared theta? What rule am I going to have to use? Chain rule. So the derivative of the outer function, so I'm going to multiply 2 times 4, which is 8, times the inner function, times, what is the derivative of cosine theta? The derivative of cosine theta is a what? Negative sine theta. So then this derivative is going to be negative 8 cosine theta sine theta. So then I have to find dy d theta. So to find dy d theta, how am I going to take the derivative of 4 cosine theta sine theta? I'm going to use what rule? Product rule. So then let's start. Here's my f. Here's my g. So what's the derivative of 4 cosine theta? Negative 4 sine theta times g, which is sine theta. So that's going to be negative 4 times sine, or negative 4 times sine squared theta. Plus f, which is 4 cosine theta, times what's the derivative of sine? The derivative of sine is going to be a cosine. So that's going to be 4 cosine squared theta. So any questions on how I found my dx d theta or how I found my dy d theta? Now, you can do trig identity substitutions if you want to clean this up. That's completely up to you. Or remember, the whole purpose is we want to find dy dx, and we're going to evaluate this at pi over 4. So I need to take my dy d theta, which I found to be negative 4 sine squared theta plus 4 cosine squared theta, and I'm dividing it by my dx d theta, which I found to be negative 8 cosine theta times sine theta. And again, I want to evaluate this when theta is equal to pi over 4. So now I'm going to plug pi over 4 into this expression for theta. So I have negative 4. By the way, what is the sine of pi over 4? Square root 2 over 2. So negative 4 times square root of 2 over 2 squared plus, again, cosine theta is going to be what? Cosine of pi over 4 is going to be what? Square root 2 over 2, also squared. All over negative 8 times square root of 2 over 2 times square root of 2 over 2. What's the value of this derivative going to be? No, look at that numerator. It's going to be 0. Because, again, no matter, don't work it all the way out because you have negative 4 times the same exact thing as positive 4. So this whole 0 divided by anything is just going to be 0. All that work for 0. So any questions on how you can find the slope of a polar equation, slope of a tangent line? Okay? Any questions on that? All right. So now, find the points on the cardioid r equals 1 minus cosine theta, where there is a horizontal tangent line, a vertical tangent line, or a singular point. So So first of all, let's start with horizontal tangent line. So remember, to find the horizontal tangent line, this is where we're going to set that numerator equal to 0, or we want to find where your dy d theta is equal to 0, and remember dx d theta is not equal to 0. So just like I had to do in the last problem, remember x is equal to r cosine theta. Just like I did in the previous example, I've got to take r out, and I have to replace it with a 1 minus cosine theta. So x is going to be equal to, make sure you keep parentheses around that 1 minus cosine theta, times cosine theta. Distribute, x is equal to cosine theta minus cosine squared theta. So any questions on where I got that x from? Y is equal to r sine theta. So now I have to take r out and replace it with a 1 minus cosine theta. Distribute the sign, so y is going to be equal to sine theta minus cosine theta. Sine theta. Boy, somebody from 6th period must be missing us. I hear the phones buzzing. Any questions on how I found the x equals or y equals? So now I want to find dy d theta. So what am I going to have to do to find the derivative of cosine times sine? I'm going to have to use my what again? I'm going to have to use my product rule. Now remember, it's following a subtraction sign, so make sure when you after you use your product rule, you keep the parentheses around it. You guys go ahead for me and find your dy d theta. So go ahead and do the derivative. Going to be cosine theta plus sine squared theta minus cosine squared theta.
Wouldn't it be cosine cubed theta?
I'm sorry?
Wouldn't it be cosine cubed theta?
No.
Oh, wait, no.
You're subtracting.
I thought we were multiplying the cosine.
Are we good? So now remember, what do I need to do with my dy d theta? I need to set it equal to 0. So 0 is equal to cosine theta plus sine squared theta minus cosine squared theta. Now you got to remember how to solve all your trig equations. Like I said, today is going to be a big pre-calc day. Remember, one of the strategies that you learn to solve trig equations is you want to make sure, if you can, get the equation in the form of one trig function if possible. We have a linear cosine, so this is where you need to remember all your trig identities. I have a linear cosine. I have a squared cosine. So if possible, try to rewrite this whole entire equation in the form of a cosine. What could I do with this sine squared? What is sine squared equivalent to? 1 minus cosine squared. So use that Pythagorean identity. So cosine theta plus 1 minus cosine squared theta minus cosine squared theta. Combine your like terms, so I end up with 0 is equal to cosine theta plus 1 minus 2 cosine squared theta. And this is where, some of you may feel more comfortable, if you want to do a substitution, take out the cosine right now and replace it with an x to get you through the algebra part. So this is just like solving an equation of x plus 1 minus 2x squared. And how would you solve any type of quadratic? What would you try first? Factoring. So if possible, try to factor this. Again, I'm just going to, I like to always factor with the leading coefficient to be positive. So imagine moving everything over to the left-hand side. That would give me 2 cosine squared theta minus cosine theta minus 1 is equal to 0. And like I said, you could replace this and write this, if you wanted to, as a 2x squared minus x minus 1 equals 0. Just let x be equal to cosine theta, if you feel more comfortable that way. So you guys go ahead and factor it for me, and see if you then can set each factor equal to 0 and finish solving that trig equation for me. So after I factor this, I should have factored this into 2 cosine theta plus 1, cosine theta minus 1. And again, you want to look on your unit circle and ask yourself, where is cosine equal to negative 1/2? Remember, cosine is negative in quadrants 2 and 3. So the angles that have the cosine value of 1/2 in 2 and 3 are 2 pi over 3 and 4 pi over 3. And then you're looking to see where is cosine equal to 1. Remember, cosine is your x-coordinate. So it's at positive 1 at a theta value of 0. Yes?
If we wrote 2 pi, would that be wrong?
Typically, it's always less than 2 pi, but it's not incorrect since the restrictions aren't explicitly given in the beginning. But 0 and 2 pi are the same location, so typically it's just less than 2 pi, not equal to. Are we good then? So this is where now we have to confirm whether or not our dx d theta is equal to 0 at these particular points. So they also want me to do vertical tangent lines. So remember, vertical tangent lines, remember, occur when dx d theta is equal to 0 and dy d theta is not equal to 0. So I know where dy d theta is not equal to 0. I know where dy d theta is equal to 0 because I just found that. So now what I want to do is I have to differentiate my x equals cosine theta minus cosine squared theta. Luckily, I don't have to do my product rule again. Because what's the derivative of cosine? The derivative of cosine is a what? Negative sine theta. Now remember, this minus cosine squared is actually minus, it's really cosine theta minus the quantity of cosine theta to the second power. So I'm going to have to apply what rule here? I'm going to have to apply my chain rule. So it's going to be minus 2 cosine theta times the derivative of the inner function. The derivative of cosine is going to be a negative sine. So that's going to make it a plus. So any questions on how I found dx d theta? So now what am I going to do with dx d theta? I'm going to set it equal to 0. So 0 is equal to negative sine theta plus 2 cosine theta sine theta. How do I start solving this trig equation? What can I factor out? I can factor out a what? Sine. So that's going to give me a negative 1 plus 2 cosine theta.
Would it be the best thing if we factored out a negative sign?
No. You guys go ahead now and finish solving it for me. You should end up with 4 solutions for this one. So hopefully we ended up with, ladies and gentlemen, 0 pi, pi over 3, and 5 pi over 3. Now we can actually go through and finish answering the questions. Because now remember, the question is asking us for horizontal tangent lines. So remember, to have a horizontal tangent line, dy d theta has to be equal to 0, and dx d theta cannot be equal to 0. So now that I have solved where dx d theta and dy d theta equal to 0, do you see any theta values that overlap, that appear in both? Yes. So that means that I do not have a horizontal tangent line at 0, or do I have a vertical tangent line at 0? The singular point, right, the singular point, remember, is where my dx d theta and dy d theta is equal to 0. So again, I know I have a singular point when theta is equal to 0. So I have 2 angles that will give me a horizontal tangent line, which is 2 pi over 3 and 4 pi over 3. And I also have 3 places where I'll have a vertical tangent line, which is at pi, pi over 3, and 5 pi over 3. Now, the question, ladies and gentlemen, is asking me for points.
Wait, we already know what R is. And we know what beta is. Oh, wait. Yeah.
Yes. Yes. It's a long question, yes. Shh. Guys, shh. Have I answered the question? What does a point look like in polar? It has not just a theta value, but it has a what? R value. Remember, a point is going to be R comma theta. So now, if theta is equal to 2 pi over 3, how can I calculate the r value? I simply just plug it back into my equation, r equals 1 minus cosine theta. What is the cosine of 2 pi over 3? The cosine of 2 pi over 3 is what? Negative 1/2. So 1 minus 1/2 is going to give me 1.5 or 3/2. So the angle, the point will be at 3/2 and 2 pi over 3. That's the point where I'm going to have a horizontal tangent line. 4 pi over 3. Again, if I plug in 4 pi over 3 for theta, 1 minus the cosine of 4 pi over 3, and again, the cosine of 4 pi over 3 is negative 1/2. So that's also going to be at 3/2, 4 pi over 3. Vertical tangent lines, pi over 3. So to find the point where I have a vertical tangent line, I know it's going to be at pi over 3, 5 pi over 3, and pi. So when I plug in pi over 3, cosine of pi over 3 is positive 1/2. And 1 minus 1/2 is going to give me 1/2. So my r value will be 1/2 and pi over 3. The other point is going to occur when theta is 5 pi over 3. Again, cosine of 5 pi over 3 is also a half. So that's going to be at 1/2 5 pi over 3. And then I've got the angle pi. What's the cosine of pi? Negative 1. 1 minus negative 1 gives me a 2. So I have 2 and pi. So those are the 3 points where I'm going to have vertical tangent lines. Now, what's my singular point going to be? Well, if theta is equal to 0, cosine of 0 is what? 1. And 1 minus 1 is 0. So the singular point will be at 0, 0. Okay? So any questions on that?
So the singular point is also the polar, or is it in the xy plane?
Well, these are points on the polar curves.
Okay.
Yeah. Okay? Now, another type of tangent line that they sometimes ask you about is when you have a tangent line at the origin, or what we refer to as the pole. Again, if you've got a tangent line at the pole, try and find the point at the pole. Again, what do we know about r values at the pole? The r value is going to have to equal what? 0. So again, the r value is going to have to be equal to 0. Again, we talked about how the derivative of y with respect to the polar is dy d theta over dx d theta. So if r is equal to 0, this whole thing goes to 0, this whole thing goes equal to 0. So notice I'm left with the sine over the cosine, which is also going to be the tangent of theta sub 0. So what that brings me to is that the slope of the tangent line is going to be the tangent of theta. All right? So if you have a polar curve that passes through the origin at theta equals theta sub 0, which is going to be the tangent line, that will occur when r is equal to 0 and dr d theta cannot be equal to 0. So what you really need to remember about tangent lines to the pole, to find a tangent line at the pole, the one thing you have to remember is r has to be equal to 0 and your dr d theta cannot be equal to 0. That's the thing when they ask you about the tangent lines at the pole you really need to remember. You find them by setting r equal to 0 and checking that dr d theta is not equal to 0 at those particular values. So when we talk about the equations of tangent lines at the origin to the curve, r equals f of theta can be attained by solving the equation f of theta is equal to 0. Like I mentioned, setting r equal to 0. And this may occur for more than one value of theta. So here's an example. Sketch the polar curve r equals sine 3 theta. Well, what is r equals sine 3 theta? A rose with how many petals? What's the length of each petal? Length of each petal is 1. What's the spacing between each petal? 2 pi over 3. So remember, we want to find the tip of one petal, then I'll know the placement of the others. So really, I know that, remember, 3 theta, I know the sine of pi over 2 is equal to 1. So really what I want to know is, where is 3 theta going to be equal to pi over 2? So what's theta going to be equal to? Pi over 6. So at pi over 6, I'm going to have the tip of my first petal. Actually, it should be closer down here to the x-axis. So since I know that the tip of my next petal has to be 2 pi over 3 units away from this, again, remember with a common denominator, that's going to be 4 pi over 6. I can take pi over 6 and add 2 pi over 3 to it, which will give me 5 pi over 6. Or remember, these sine curves have symmetry with respect to your line theta equals pi over 2. So I can take the tip of this petal at pi over 6, reflect it over into quadrant 2. So the tip then will be at 5 pi over 6. So then to find the tip of my third petal, take 5 pi over 6, add 4 pi over 6 to it, which would be 9 pi over 6, which reduces to 3 pi over 2. Okay? So there's the sketch. So now let's talk about, before I go any further, remember, I'm not finding points, I'm finding lines. The question's asking me to find the polar equations of the tangent lines. So let me bring up a polar graph for a minute. I just grabbed an old, if you remember, ladies and gentlemen, when you studied polar, this is an example of what a polar graph looked like. If you remember from your pre-calc days, the way you write equations in polar, it was theta equals the angle measurement. So for example, when you saw an equation of a line in polar, it wasn't in the form of r equals, it was theta equals, if you remember. So if I asked you to sketch the line theta equals pi over 6, I just said go to the angle pi over 6 and draw your line. No.
Oh, okay.
Refreshing your memory a little bit.
Remember this.
Is there another way I could write the equation of the line for theta equals pi over 6? Theta equals 7 pi over 6. What happens when you start writing equations of lines greater than pi?
They start to double.
They begin repeating themselves, don't you? So when you are trying to solve, and the reason why I'm bringing this up is because when you start solving and the question is asking you to write equations of lines, when you're solving your trig equations, you can stop when you get to pi. Because of that reason, you become repetitive. In other words, in your list, you're not going to write me an equation of theta equals pi over 6 and theta equals 7 pi over 6. It's exactly the same line. So now let's talk about this particular problem. Remember, to find a polar equation of the tangent line at the pole, we want to find where r is equal to 0 and dr d theta is not equal to 0. So what I'm going to do is I'm going to start solving the equation 0 is equal to sine of 3 theta. Thus, this is the point of the warm-up that I gave you this morning. So now, you want to start by finding where is sine equal to 0. Well, sine is equal to 0 where? At what theta values? At 0 and pi. So then I have to do my general solution. 3 theta is going to be equal to 0 plus 2 pi k. Divide by 3. So theta is going to be equal to 0 plus 2 pi k over 3. So when I plug in 0 for k, I end up with theta is equal to 0. Theta is equal to 2 pi over 3. And then I could keep going if you wanted to. 4 pi over 3, etc. But now remember I have this other angle. So I have to take 3 theta, set it equal to pi, plus 2 pi k. Divide by 3, so theta is equal to pi over 3, plus 2 pi over 3 times k. So then theta is going to be equal to pi over 3, and then 2 pi over 3 plus pi over 3 is going to give me pi. But what do you know about the line theta equals 0 and theta equals pi?
It's the same.
Same lines. So at this point, these are my candidates. I said candidates, where I will have my tangent lines at the pole. How come I did not say solutions at this point? Because what do we have to check? We have to check to see where what? dr d theta can't be equal to what? 0. So I have to find dr d theta. So
I'm wondering, so we found theta values.
Right. These are my possible candidates. I have to check to confirm that dr d theta is not equal to 0 any of these angles.
Okay.
So r is equal to sine 3 theta. I have to use my chain rule. So it's going to be 3 what? So it's going to be 3 sine of 3 theta. It's not enough room. Actually, it's 3 times cosine
Okay.
of 3 theta. All right, you guys go ahead now and solve that for me. Since I did the sine one, you guys go ahead and do the cosine one.
Do you do the same process?
Yep.
Because I definitely don't have enough.
Divided by 3 already. I ended up, again, like I said, it's not incorrect if you went all the way up to 2 pi. It's just your answers become repetitive. So when I saw this, I stopped at pi. So any questions where I got pi over 6, 5 pi over 6, or pi over 2? So now what you want to do is check. Check these answers against where r was equal to 0. So again, if any of these overlap, you have to reject them from your solution set. So notice pi over 6, 5 pi over 6, and pi over 2 is at no place where r is equal to 0. So all of these lines are going to be tangent to the pole. Any questions on example 3? All right, last one, and we're done. Go ahead.
Which ones are the ones that are the actual?
These.
The person.
Yeah.
Okay.
Remember, if you found any of these angles, you have to check to find where dr d theta is equal to 0. Because if there is any place where dr d theta is equal to 0 and r is equal to 0, you've got to reject it.
Yes. And so, okay, the second time we were just looking
Yeah.
for.
Yep. So, guys, remember, we've got 3 different coordinate systems. We've got 3 different coordinate systems. We've got the rectangular, you've got parametric, and you've got polar. So we talk about arc length. You've got an arc length formula for each system. So again, we talk about the arc length formula for polar curves. Still the same idea. We are still trying to find the distance around a curve. Guys, shh. So when we are solving for these arc length problems for polar curves, your bounds are now going to be angles. So the formula for arc length in polar, again, we're going from alpha to beta. It's going to be the square root of r squared plus dr d theta squared d theta. just a reminder of the other formulas. If you're trying to find arc length for rectangular, and remember this is where you're dealing with x and y, the arc length formula is going to be from a to b, the square root of 1 plus dy dx squared dx. That was back in chapter 6.
I do not recognize that at all.
Sorry.
We did it back in chapter 6. That's why I'm writing it down, because we did it back in chapter 6.
I memorized that equation.
Parametric. Shh. Guys, come on. Parametric. So we have x of t, y of t. Again, when you're trying to find the arc length for parametric curves, again, we're going from a to b, square root of dx dt squared plus dy dt squared dt. Yeah. So you've got to know these three formulas. These could be calculator, or these could be no calculator questions, but you must always show your setup, remember, when you're doing these. So, for example, calculate the arc length curve of your polar curve for the entire cardioid. So remember, with this cardioid, just to give you a rough sketch, what you're trying to do is calculate the distance around that whole entire cardioid. Now, the question is, guys, what are your bounds going to be? Your bounds are going to go from what?
0 to 2 pi.
0 to 2 pi. So now R is obviously this equation 1 plus cosine theta. What is your dr d theta going to be equal to? What is dr d theta going to be? What's the derivative of 1? Derivative of 1 is 0. Derivative of cosine is negative sine. So then dr d theta squared is just going to be sine squared theta. So now I can plug what I know into my formula. So the square root of 1 plus cosine of theta squared plus dr d theta squared, which I found to be sine squared theta d theta. So you guys go ahead and plug that into your calculator. Again, you don't need to be in polar mode. You don't need to change your mode into polar. All right. Just make sure, however, the angle measurement should be in what mode? Degrees or radians? Radians. So like I said, just like all the other arc length problems, guys, these could be calculator. These may be no calculator questions. All right, so just make sure you're loading your functions 1 plus cosine under y1. Load the sine under y2 so you don't make a squaring error with parentheses. All right, one more problem. The spiral, r is equal to e to the theta between 0 and pi. So first of all, they're giving you your bounds. So I know my bounds are going to go from 0 to pi. So now to take a look to see what this graph looks like between 0 and pi. Well, again, if I plug 0 in for theta, what is e to the 0? E to the 0 is just going to be what? 1. So at theta equals 0, I have the point 1. When I plug pi in for theta, e to the pi, e raised to the pi, oops,
Like a lot.
is 23.141. So it looks something like this. And again, if you want to look at it on the calculator,
It's like 23.
it's like 23.141. So again, if I, now you do have to, if you want to graph this in polar, you do have to change your mode to polar. So my y equals, again, when I type in r equals e to the theta, remember, go to your window, change your bounds from 0 to pi. Now remember, ladies and gentlemen, you're going to have to take this x min and x max, you're going to take that x min out to about something greater than negative 23, so I'll take it out to negative 25. Because you got to see it past that negative 23. Okay. Spirals is something we don't really cover in terms of how to graph it by hand. You don't need to know how to graph a spiral by hand. All right? That's why it says graph using your calculator. All right. So then let's talk about how I'm going to find the arc length. I know r is equal to e to the theta. R squared would be equal to e to the theta raised to the second power, or e to the 2 theta. Dr d theta. Dr d theta, well, the derivative of e to the theta is just going to be what? E to the theta. So then dr d theta squared is going to be e to the 2 theta.
Wait, why did we square it?
Because I'm going to plug it into my formula.
Yes.
So you don't have to square.
Exactly. So now I'm going to plug it in. Square root of r squared is e to the 2 theta. Dr d theta squared is e to the 2 theta d theta. E to the 2 theta plus e to the 2 theta is going to be what? 2e to the 2 theta. How am I going to integrate this by hand? Well, what constant can I pull out? I can pull out a what? Square root 2. Square root of, now remember, e to the 2 theta was actually e to the theta squared, correct? So then what is the square root of e to the theta squared? E to the theta. Oh, no more square root. And what is the integral of e to the theta? The integral of e to the theta is just going to be what? E to the theta. So square root of 2 times e to the theta, and again, I need to evaluate this from my bound 0 to pi. Now, remember, don't assume just because that lower bound is 0, you can ignore it. So when I plug in my upper bound and plug in pi for theta, I end up with square root of 2 times e to the pi minus, what is e to the 0? E to the 0 is what? 1. I just kept the constant square root of 2 factored out. So your final answer is going to be square root of 2 times the quantity of e to the pi minus 1.